First of all, I would like to thank the organizers of Samvad for giving me this opportunity to present my research talk in this forum. My today's Samvad talk is titled Transforming Healthcare with Advanced Dialogue Systems. The overview of my today's talk is that I'll briefly discuss the primary working modules of a dialogue system, followed by two popular paradigms of a dialogue system, namely modularized dialogue systems and end-to-end dialogue systems through the lens of healthcare applications. Moving forward, in the recent years, there has been a significant surge in the deployment of dialogue systems across various sectors of customer interactions. In 2018, almost 30% of all the customer interactions were facilitated through emerging technologies such as AI-driven chatbots or virtual assistant. And fast forward to 2024, this number now stands at about 70%. In terms of the market size of AI-driven dialogue systems, the market has also expanded considerably. In 2020, the market size was valued to be about $5 billion, and it is estimated to increase to about $14 billion by the year 2025. So we can see that there has been an exponential increase. And this highlights the substantial investment and trust the industries are placing in these advanced communication tools, which is kind of revolutionizing the way we interact with customers, particularly in the field of healthcare sector. Also have a very interesting statistics to highlight the interest of the research community in the innovations related to dialogue and interactive systems. We have the number of submissions made in top rated NLP conference, which is the conference ACL in 2020. And we see that dialogue and interactive track rakes in one of the highest number of submissions just behind machine translation track. So that is how much, the interest the research community takes in dialogues and interactive systems in general. In the context of the current state of the art in healthcare, the world falls short of about 7.2 million medical workers currently. And this shortage is expected to rise to about 30 million medical professionals by the year 2030. Right? So this is the massive dearth we have of medical professionals all around the globe. Also, a recent survey conducted by the World Health Organization shows that about 35% of the adults in the United States used some kind of AI-driven self-diagnostic tools before consulting with a general physician or doctors. So this really motivates the need and utility of virtual agents in healthcare in several ways. For example, remote monitoring, right? So the virtual agents can actually, collect and analyze vital signs of patients' health, and also, alert the healthcare providers in case of any anomalies. Also provide real-time feedback to the patients, help give them reminders for medications or lifestyle adjustments. In the realm of clinical decision support, these virtual agents can actually assist healthcare professionals to quickly analyze the patient information and provide recommendations for potential diagnosis of the disease or treatment options, right? And this kind of advanced tools are actually valuable in situations where the doctor to patient ratios are quite alarming. And as we all know, mental health is still considered to be a big social stigma. People have the fear of being judged. They are still shy to open about their mental health well-being. So these kind of virtual assistant can actually, act as a private and a non-judgmental resource for them to seek help. So this can actually encourage people to seek help and manage their mental well-being more efficiently. Now, coming to a bit of details of a dialogue system, a dialogue system is primarily known to comprise of three basic modules. First, we have the natural language understanding module. This module is responsible for making sense of the user input. It basically extracts relevant information from the user input, ranging from coarse-grained to fine-grained information. And this module in turn comprises of several other submodules, for example, dialogue classification, intent detection, slot filling, emotion recognition, sentiment analysis, humor, sarcasm, all the nuances of human behavior and communication. And LU is responsible for extracting relevant information out of it. So for example, Say if the user says, show me cheapest flights from Pittsburgh to Denver, right? How does each of these NLU module work? Say the dialogue act is responsible for identifying the communicative intention of the user. So here the communicative intention of the user is command, right? The user is actually kind of commanding the virtual agent to show it the cheapest flights from Pittsburgh to Denver. This dialogue act module works on a sentence level basis. Similarly, we have intent classification, which is responsible for identifying the true communicative and not communicative, true intention of the user. For example, here the intent of the user is to know about the flight and also the cheapest airfare. And this also works on a sentence level basis. And next we have slot filling, which works on a token level basis. So it basically extracts relevant token-wise information from the user utterance. So in this case, the important information is the arrival city and the departure city, right? So in this way, from coarse grain to fine grain information, the NLU extracts from the user input. And this information is then updated in the state space of the virtual agent to further pick up relevant actions to interact with the user. So the next module in pipeline is the dialogue management module. This module is responsible for deciding the flow of the conversation in any kind of dialogue system, right? So it takes in all the information which is extracted from the NLU module and outputs an action to interact with the user given the state space, right? So it has two tasks to decide whether sufficient information has been elicited from the user and then pick up an action. And that action can be in the form of two kinds of action, either communicate with the backend application or communicate back to the user. So typically, we model this problem as a decision-making problem using reinforcement learning. So task is to map states to action to achieve a predefined goal. So here the goal is to basically maximize a reward signal. And then the next module in pipeline is the natural language generation module. This module is responsible for converting the action picked up by the virtual assistant into a natural language. So to give you an example, say the user says, who is the director of Titanic? So the agent picks up an action, reply director, for which it makes a database query to fetch the answer, James Cameron. Now, how to present this information to the user? Just generating James Cameron or saying the director of Titanic is James Cameron. This decision is being taken by the natural language generation module. So there are, like I said, two popular paradigms of dialogue systems have emerged in the recent literature. First is the modularized dialogue system, which I just explained right now. It is a pipeline framework having multiple modules, the NLU, dialogue management, and the NLG module, where the dialogue management is at the core to learn a policy. And this kind of dialogue system is particularly beneficial for task-oriented conversations where there's already a predefined goal of the user. For example, a restaurant booking virtual assistant, right? So the user comes and says, help me book a restaurant, Chinese restaurant, for today's, for example. So there is already a predefined goal, and the agent will navigate and interact with the user to help achieve the goal, right? The good side of these kind of dialogue systems is that it is easy to scale up. Another kind of dialogue systems which have emerged in, I would say, in the last 6-7 years is the end-to-end generation framework, which completely skips all these modules, the DM, the NLU and things like this, and only has one module. One single module is doing everything: interpretation, learning a policy, and also generating the responses that we call as the generative models, right? So you give the dialogue history and the input, and it will give you a response. Various lines of research have emerged in this area. For example, knowledge conditioned response generation, aspect grounded response generation, and so on. The good side of this is that we do not require any feature engineering. You just give the input, you get an output. But the flip side of it is that it is extremely resource intensive. You need to feed it a huge amount of data. It is computationally intensive. You need to give it good computational resources to train a robust model that can do really good stuff. So today we are going to explore these two paradigms of dialogue systems through the lens of healthcare applications. So first is the modularized dialogue systems. And for this, I'm going to explain this work on medical care titled Symptoms Are Known by Their Companies Towards Developing a Virtual Diagnosis Assistant with Association-Guided Symptom Investigation. Yes, sir, please, absolutely. Yeah, yeah. This one? Yeah, yeah. It depends how. Yes, 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 yes. So you basically, whatever we are saying, we need to map it to a word embedding. No matter what natural language you're using, ultimately what these model takes as input is word embeddings, which are like continuous values of vectors, right? So you you get word embeddings from maybe say fast text embeddings from Facebook. It caters to about say 132 languages around the world. So you give it, it will convert it into a word embedding. And what this model basically takes is the semantic information, irrespective of the language. These are language agnostic. It will basically take the meaning of the word that you're saying. So the language, what language is seeing, person is speaking requires syntactic analysis. But what the person is saying requires semantic analysis, right? So the language is basically comes from the grammar. So you need syntactic analysis. What language, what grammar? Yeah. So that can be a model on top of that, which identifies what language, but that is irrespective, right? Even if we understand, we ultimately need word embeddings from somewhere and just feed it to the model to generate a response. And that response will then be converted into some language to present it to the, so machine translation. Even if the model is responding in English language, we can have a machine translation unit that can convert it into Telugu, let's say. Yeah, yeah. Yeah. Yes, yes, there are a lot of research in this area, like code mix. We call it code mix language. So some in English, some in Hindi, things like this. Yeah. So what do we actually mean by a disease diagnosis assistant? It is actually a virtual agent, a kind of a virtual doctor, which is responsible for investigating and analyzing the symptoms and identifying the patient's disease, right? So say a user or a patient gives a self-report to the virtual doctor, which says, say, for example, hi, I've been suffering from fever for a few days. Also, something happened in my mouth. Please see this. Based on which the virtual agent will interact with the user in a conversational framework to investigate further symptoms. For example, the doctor asks, virtual doctor, did you recently vomit? Yes, I vomited yesterday. Have you observed any skin issue? See this. To do what? To ultimately reach a conclusive diagnosis of a disease, right? So for example, in this case, the diagnosis made by the virtual doctor is the patient is suffering from fever, mouth ulcer, and so on. Or either suggest appropriate lab examinations or clinical tests. After which, this diagnosis is sent to a real doctor who will ultimately make the final diagnosis in the treatment. So these kind of assistant actually act as what? A supplementary tool, an assistive tool to alleviate the burden of healthcare professionals. Typically in situations where I said, for example, that the ratio of doctor to patients are quite alarming, right? So this is what we want to model. Yeah, so the doctor does not have to invest time in doing the symptom investigation with the user. Are you suffering from this? Are you suffering from this? Yes. Yeah. So we model this problem as a decision-making problem with the help of reinforcement learning. Apart from this, what we want to see, the idea behind this work was, like it is said, a word is known by the company it keeps. Similarly, symptoms also exhibit the association property. That is, one symptom may strongly suggest another symptom's existence or non-existence, right? That means what? A disease is described by a set of symptoms, and we want to investigate the association amongst these symptoms to identify the disease efficiently. So the contribution of this work was that we wanted to investigate the role of symptom association in the diagnosis process, and then we proposed a association-guided symptom investigation-based diagnosis agent. Yeah, figuring out which action to pick up to communicate with the patient. Yes. So for this, we made use of the popular options framework that belongs to the class of hierarchical reinforcement learning. Why hierarchical reinforcement learning? Because it gives you a framework to decompose composite or complex tasks into multiple subtasks, right? So analogous to its literal meaning, we have hierarchy of policies. We have a top level policy known as the controller policy, which is responsible for activating one of the departments, say ENT or a pediatrics. For example, say you get into an hospital and say, I'm suffering from fever. So the person will designate you to maybe say a general physician, right? Or maybe if you say my eyes are paining, so they will designate you to a eye specialist. So this is what the top level policy is doing, activating one of the departments. And then we have a lower level policy known as the departmental policy, which is responsible for conducting group specific symptom investigation. That department will now investigate symptoms with you depending on your initial self-report. Right. So at each time step of the conversation, the task of the agent to decide whether sufficient information has been extracted from the user in order to make a correct diagnosis of the disease or to still further investigate the symptoms, right? So based on the action that has been picked up by the agent, it receives a reward from the environment to learn a policy. So a typical RL setup, we have the virtual doctor, the patient is the environment with which it is interacting. It picks up an action, present it to the patient, it will get some kind of reward signal to learn a policy, right? Now the user is only interacting with the lower level policy. The abstraction present in the system is not known to the user, right? Next, apart from this, we have two other modules, an association module and a recommendation module, which is responsible for providing two kinds of information to the virtual agent at every time step of the conversation. First is the association module, which gives an association score to the virtual agent, which indicates how relevant the current symptom or action of the virtual agent is, based on the initial self-report or the state of the system, right? So it in the form of a critique. So basically it is a reward signal. And the recommendation module will provide what? A list of top key symptoms that the agent should actually investigate given the current state of the conversation. So that means, say if your action space contains 200 symptoms, it will give a list of top key symptoms. So decreasing the or reducing the search space of the agent to pick up relevant actions, right? And then we emulate this association and recommendation module using a knowledge graph where the node represents symptoms and the edges represent, an association score based on the intensity of the occurrence of the two symptoms in the data set. Yeah, and also the task of the agent is to decide whether, like I said, sufficient information has been elicited and whether when to move to the disease classifier to ultimately make the diagnosis of the disease. And so this disease classifier is a very simple, two-layer MLP, which takes in one hot encoding of the symptoms investigated, which are confirmed, unconfirmed, and ultimately makes the diagnosis of the disease. Yeah, I think pretty much this is it. Right. So yes, sir. Yes. 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 Yeah. 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 So during training, this is what we want the virtual agent to learn. Pick up the correct department. So we need to emulate this using reward signals. So say during training, the model picks up an incorrect department. It will not receive good rewards from the lower level policy. It will be penalized for that action. So in the top level policy, it is basically options. Yeah. It might happen. There can be a dialogue which is unsuccessful. So the success rate is not very good. This is a very challenging problem. You have 266 symptoms, out of which how can you investigate only 10 symptoms and identify the disease of the user? That is a challenging task. So yes, still it is an ongoing effort. Not absolutely perfect, but yeah. Yes, sir. Yeah, true. That can happen. Yeah, so this is where the association score comes in, right? If say I am having breathing issues and the model suddenly starts asking about some leg pain, say, so that is not a relevant symptom to be investigated. Sometimes it could be, yes, yes, yes. So it depends on the association of the symptoms in the data set. If there is good number of association between two symptoms, then it will be picked up in the top K list. So for example, when we talk about cold, the next symptoms that comes to our mind is cough, right? So given cold, cough is one of the relevant symptoms to be investigated because they often co-occur together. So that is the idea behind this. Yes. 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 So at the moment, this is a patient simulation. We don't have real patients actually sitting and doing it. So it's a patient simulation. We have a set of implicit symptoms that the patient, explicit symptoms the patient will say beforehand, and some implement symptoms which say the virtual agent will ask, and based on what is given beforehand, it will respond accordingly. So this is all simulation based. No real time testing has happened yet. Yes. Yes, I will get to that. Yeah. So this is only for physical health. For mental health, we cannot have a modularized dialogue system, which I'll explain just after this. Yeah, because we cannot discretize actions in mental health. A counselor will not just ask you, are you panicking? Are you having anxiety? Are you not eating food? Are you not sleeping? Right? It is always the mental health conversations are often noisy in nature. You cannot discretize actions. So we cannot use modularized dialogue systems for mental health. Yeah, yeah. I mean, when you have these AI technologies, you should be ready for everything that can happen. Yeah. I mean, there is flip side to everything. Yeah, you've got to counter it. Yeah. So yes, so we compared our proposed methodology with various state-of-the-art models with the help of different standard metrics. For example, the diagnosis success rate, dialogue length. So you can see that this is the dialogue success rate. In the x-axis, we have the training samples. No, not training box. Sorry. So this is our model ASIDS, green one. You can see that the success rate overall is about only 0.5, like 50% of the conversations where the agent was successful in order to diagnose the correct disease. 50% of the times it was unsuccessful. But it is still better than state-of-the-art models. Okay. So one problem with the standard matrix in this scenario is that since these matrix is good for finding out the overall performance of the system, it is not good for understanding the relevance of the symptoms being investigated, right? For example, like I said, say I have breathing issues, but this model suddenly starts asking me about, say, leg pain or skin issue, which is not related to my condition. I might get frustrated and end the chat, right? Because ultimately these are our virtual agent. It is a discretion of the user to end the chat, right? So how do you ascertain whether correct symptoms were investigated by the agent? For that, we proposed metric investigation relevance score 1 and 2. And based on that also, we see that our proposed model performed better compared to the state-of-the-art models. This is the result on the departmental level policy, right? D1, D4 basically represents the different departments, the disease group. We can see that consistently our model performed better than the state-of-the-art models. Again, it's not completely perfect, but yes, it's an ongoing effort. Yeah. Any questions so far? Yeah. So moving on. Next, we come to the end-to-end generation framework or the end-to-end dialogue system. And for this, we are going to explore this topic in the context of mental health, treatment and care. The first work that I have is a motivational virtual assistant for assuaging mental agony. This work was recently felicitated in the NASSCOM AI Confluence with the NASSCOM AI Game Changer Award in the AI research category. We all know that, we all don't know, this is the statistics that about 970 million individuals suffer from some sort of mental or neural diseases, making it one of the primary causes of disability globally. According to World Health Organization survey, more than 300 million individuals worldwide suffer from depression, which is a drastic increase of 18% between 2005 to 2015. And with the onset of COVID, this number has worsened a lot. However, poor access, like I said, the doctor to patient ratios are not really good. Stigmatized experience, the fear of being judged, shyness, and prejudice presumably restricts the clinical care to just 15% of the people affected. Only 15% of the people affected really go and seek help from real-time mental health professionals. What is the motivation behind doing this work? Like I said, there is a lot of social stigma and bias still attached to mental health. So people resort to share their feelings anonymously. For this, they go to peer-to-peer support platforms to seek help. While support givers in these platforms are really well-intentioned in their effort to support seekers, but they are not aware of the best practices in therapy, and this leads to wasteful engagement or conversation. Thus, there's an explicit need to come up with an end-to-end VAs for providing support to mental health support seekers. So motivated by this factor, the contribution was that we wanted to create a virtual assistant that is capable of providing motivational support to support seekers, right? And for this, since there was no such data set in place to conduct such a study, we curated a data set called Motivate, which actually is a dyadic conversation mimicking a mental health patient and a virtual agent. And these conversations were, curated from actual conversations collected from peer-to-peer support forums. Now, an interesting question that sir did ask me, why can we not use modularized dialogue systems in mental health? Why we have to switch to end-to-end generation frameworks? The reason is that mental health conversations are often very, very noisy because the support giver or the counselor has to use different ways of communication to make that person feel at ease in order to extract information out of them, right? This makes the conversation noisy, and this makes it difficult to discretize actions. So symptom investigation is not explicit in mental health. Whereas in physical care or medical care, symptom investigation is explicit and which can also be supported through clinical tests, right? And because of these limitations, we have to resort to end-to-end generation frameworks for mental health. Now, before getting into the details of this work is purely meant to be non-clinical in nature. The task of the agent is not to replace a counselor, not to give any kind of clinical therapy-based advice. Yes, sir. Yes. Yeah, I have some examples. Conversation is, I'll show just in a moment. Right. Yes. 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 I'll say that. Yeah. So in medical care, say I am having stomach pain. If the doctors ask me, are you having stomach pain? I know because I can feel it. For mental health, patients do not know how to describe their symptoms. Often we have observed that persons suffering from depression and persons suffering from anxiety express their problems in a similar way, although they are two different diseases. One is a neural disorder, one is a mental disorder, right? People really do not know how to express their feelings. That is the problem. So, like I said, symptom investigation is not explicit. Whereas in medical care, if I have leg pain, if I have stomach pain, if my mouth is burning, if a doctor is asking me, I can tell that. But in mental health, the counselor has to understand in between words what the person is actually suffering from, right? So it makes it a challenging task because the person suffering from mental health often share common linguistic patterns and nuances of communication. If that answers your questions. Yeah. Yeah. Yes, yes, yes. Just in a moment. Yes, yes. Yeah. Yeah, that is the challenge, right? You want the model to be empathetic, also give you motivational, hope-seeking advices. So that is what we are trying to do over here. Yeah. Yeah. So again, like I said, a disclaimer, this is not meant for clinical advice or therapy. It is absolutely meant to be non-clinical in nature, right? So the task of the virtual assistant is to comfort the user, allow them, allow the users to share and express their thoughts, moods, feelings, emotions, struggles, and worries. In turn, what does a VA should do? It should impart optimism, hope, and motivation advices, which are identified as crucial effective factors to uplift the spirit of the support seekers in distress. This has been established in psychology, that if you interact with mental health patients and try to give them hope and motivation to look forward in life, it helps to uplift their spirit, right? In turn, in terms of natural language, the virtual agent should provide very accurate responses to give a natural human-like experience by responding empathetically and affirmative, right? So this is the entire task. Now, since, like I said, there was no data set in place, it took me almost 1 year to come up with the data set. So the major focus was on the data set, and then after which we came up with the model. So we scanned existing literature, but we couldn't come across any data set catering to such a scenario. So we scanned the internet for various peer-to-peer support platform, web-based platforms, and then we zeroed down for further investigation of our problem statement. So on online web-based platform for anonymous users to share their state of mind anonymously. So in this platform, you have several sub-forums relating to different mental health disorders. From that, we selected 4 sub-forums, depression, anxiety, obsessive compulsive disorder, and post-traumatic stress disorder. And we collected about 10K multi-party conversations. I say multi-party because say a person has posted about his or her feelings, a lot of people will comment back and forth in that conversation. So it's not a two people conversation. It's a multi-party conversation. So we collaborated with psychiatrists in AIMS Patna to curate guidelines to convert this multi-party conversation into a dyadic conversation, mimicking a scenario between a patient and a virtual assistant, right? So we seeked help from them in the terms of the virtual agent, what qualities a virtual agent should have, not in the conversation side, right? So some of the guidelines that we curated were, for example, the VA cannot impart any medical advice, right? Because even if the user is asking for it, because it was present in the source conversation, because we do not advocate the virtual assistant to take over a mental health professional, right? Also, the VA should always respond in a positive and affirmative manner. For example, negative utterances from the commenter such as, I know nothing can change, we have to struggle throughout, were modified to display optimism like, life is indeed a struggle for all, but one needs to always fight back and be strong in the face of adversities, right? So we trained annotators who really invested a lot of time to convert these multi-party conversations into dyadic conversations. So from 10K, we landed up into 7K conversations. We had to reject 3K conversations during the quality control check. So ultimately, the Motivate dataset comprises of 7K conversations amounting to about 30K utterances for 4 mental health disorder categories. These are some of the conversations. I think this one is from the depression subthread and this is from the OCD. So you can see the user is saying, I'm really struggling to not take more sleeping pills and just pass out. I want to not wake up for a week. I feel worthless of myself not doing anything. I want to take the easy way out and just slip away. So the virtual assistant is saying, that's not you talking, user. It's a depression. Give yourself some TLC. Do something you love, like you are here for a reason that you're not allowed to know about. Hugs and keep venting. Then again, the virtual assistant will say, it's very easy to go from 2 to 3 to 4. The recommended doses is there for a reason. And unless you're a medical professional, you should follow what they say. So this kind of conversation between the user and the virtual assistant. This is from the OCD subthread. So, okay, now coming to the proposed methodology. Our end-to-end framework has 2 submodules. First is the mental illness classification framework, and then is the mental illness condition motivational dialogue generator framework. The MIC framework is responsible for deciding the mental health state of the user, right? Whether it is depression or anxiety or why do we want to have this information while generating responses? Because we want the generator framework to generate diversified responses, catering to different mental health conditions. We do not want the model to generate, common responses for all kinds of mental health diseases, right? So for this, we want to condition the response based on the mental health state of the user. This is a very simple classification model. We take the representations of the seeker utterances and virtual utterances from a BERT-based representation model. And then we have a dual attention subnetwork. We pass it through BILSTMs for learning token-wise representation. And the dual attention subnetwork has 2 kinds of attention. Self-attention, simply taken from the transformer block, and the cross-attention, which typically learns contextual representation. So say I want to learn the contextual representation of a seeker utterance, but I want to do it keeping in mind the response of the virtual agent. So cross-attention. And then ultimately pass it through the classification layer to get the mental health condition. This is a pre-trained network. We train it beforehand before the dialogue generator framework. And every time or step of the conversation, this will give the mental health state of the user. And this is used to further condition the response in the dialogue generator framework. This is a dialogue GPT model based on the GPT-2 version. So dialogue GPT small model based on the GPT-2 version. So first we fine-tune the model simply using a language modeling task, the categorical cross entropy task. And then we further fine-tune it using reinforcement learning based objective, where the rewards that we use are blue score and Rougeol score. These are scores which basically tell you how correct your responses are compared to the ground truth. So we use this as a reward because we want the responses to be as closer to the ground truth. And why do we use sentiment score? Sentiment score is because our hypothesis was that if we want a virtual assistant to be optimism and motivational inducing, we want the responses to be positively oriented in nature in terms of sentiment. Now, one could ask, why not take emotion and why take sentiment? With emotion, the problem is that emotion caters to a wide spectrum of moods, whereas with sentiment, you get an overall impression or view what people get after consuming a piece of content, right? So it's easier to monitor that way, manage that way. So for us, responses which are optimism, hope, and motivation inducing should be positively oriented in nature in terms of sentiment. Now, where do I get the sentiment score? I already have a pre-trained classifier, which will give me the sentiment score whenever the responses are generated. And if the responses are actually positively oriented, it will get a high positive reward. If it is not, it will get a negative reward. And all this together helps the model to generate responses which are motivational inducing and as closer to the ground truth. Yes, yes. Yes, yes, absolutely. No, in colloquial terms, in colloquial terms, we say emotion and sentiment the same thing, but actually they are different. You can say sentiment is a superset of emotion. Emotion are much more fine-grained in essence, whereas sentiment is an overall impression we get. So say positive sentiment could be joy, happiness, surprise, but negative sentiment emotions are fear, anxiety, anger. So they're two different things actually. Yes, sentiment is, superset. Means fine-grained feelings and mood. Say, if I say I am having negative sentiment, what kind of negative sentiment I am having? Negative sentiment could be the fear, right? Either angry, either anxiety, anything. With sentiment, you do not understand the fine-grained aspect. With emotion, you get the fine-grained aspect. Yeah. Yes, I had other work is actually focused on how emotion and sentiment affects the mental health state of the user. The other work is focused on that. No, we have not considered hormone because we don't have any data set to study such a task. Yeah. Yes, true. So this is NLP. It's only based on language that we can do, right? Yes. Yeah. So, sir, from the sub forum that we sourced, whatever conversations belong to whichever sub-forum, we gave it that. Because we didn't have annotators who could go through the conversations and really, because we didn't have any annotators who belong to that kind of background to do it. So yes. So we are assuming that the person who commented in some forum already knows that he might be suffering from depression or anxiety or OCD or PTSD. So that's the assumption. Yes. Yes, true. We have taken a simplified assumption because we don't have the data set like that, where one person could have multiple disorder. Yeah. Right. Now coming to the results and analysis. So this is the results for the MIC framework, the classification framework. K is equals to 1, 2, T means, say K is equals to 1, the conversation has just started. There is no context. K is equal to 2, that means we have context of the previous time step. And K is equals to T, that means towards the end of the conversation. So we see that as the time step increases, the classification accuracy of the model also increases. That means with the context, the model is able to distinguish the mental health state of the user better, right? But again, it's not very good performance. But in the like later iterations of the work, we have good classifiers also. Yeah, four classifiers. And this is the response of the results of the generative framework. The embedding is basically semantic metric. It basically checks the prediction based on the semantic similarity with the ground truth. Whereas blue and Rugel's score is based on token-wise similarity, whether 2 is there, the token-wise similarity. It does not look into the semantics. And perplexity is basically how confident the model was when generating the responses. So for these embedding and blue Rugel score, higher the better. For perplexity, lower the better. So we see that our model performed well compared to other ablated versions of the model. And we could not do a state-of-the-art comparison because when we did this study, there was no existing model that we could compare to. But again, the results can be improved more. So that's the finding. So I think in the interest of the time, I'll skip some and show you some responses that were generated based on the seeker utterance. So say the user says, I know I have no control. This could have happened to anyone. And when the crisis came, I did everything I could. So the response generated by our model is, you have done everything you can take care of your child and keep yourself busy. I know this is just perception, but sometimes it helps when you focus on something simple that satisfies your mind. So these kind of responses. But again, we, while doing a human evaluation, we figured out that there were issues and that can be countered. Like I said, apart from the quantitative evaluation, qualitative evaluation, we also did human evaluation where we took responses generated by the model, gave it to an annotator, and asked them to rate the responses based on some matrix, for example, fluency, adaptability, motivational, and so on. I mean, if we didn't have the dialogue GPT model, then it could have generated something very inappropriate. So do you mean something syntactically incorrect or semantically incorrect? Yeah, yes. Mm. Yes, yes, yes. So, yes. So one trade-off that we didn't encounter is that the model also needed to be empathetic, that we didn't consider while working on this paper. Always, if the agent starts to give some positive and motivation, the person will run away and not talk to the agent, right? So the agent should also like understand and resonate with the feelings of the user, and then in a way give some hope inducing advices. So because of this, we were seeing that it was always so positive and so motivation inducing that it kind of seemed like unrealistic. So this is what we didn't look at that time in the paper. Then we thought that no, empathy is also important. So yeah, it was added, not in the data set because we couldn't do anything on the data set part. I have not included that work over here, but then we came up with an empathetic rewriting framework. So the responses that were generated from the motivational framework were passed to an empathetic rewriting framework to convert it to induce some parts of empathy. Yeah, yes. In elderly care also, we can use this kind of model. I mean, we really have to see. I mean, we have not tested it in real time to see what areas we could do it. I mean, this is just on the test bed research side, all this is happening. Yeah. Yes, sir. 4 and then generating response. Yeah. Yeah. So in the recent, not in this work, but in the recent line of work that I'm doing, we're also looking at severity of the disease. Yes. That this time we didn't consider. This is the work I did in 2022 during my dissertation. We don't have anything for that. Yeah. Yeah, no, now it only caters to this. Yes. I mean, the model is not perfect yet. Yeah, so we are trying to include sentiment, emotion, severity to see how we can, make the responses more appropriate. Yes, absolutely. Yeah. No. Only just, for example, some kind of, oh, during the quality check, the responses, no, we didn't send it back to the like real time. Is like we had only just real people doing it, like general people. During the quality check of the data, when it was annotated, we sent it to them, and then a lot of things were cut down based on what they told us, and something that we could also figure out ourselves that okay, this is not making sense because something which is based on human annotation, there can be error, right? A lot of people if they are doing it. So yes, sir. Yes, I mean, yeah, all this is doable. We don't have the data set and the means to do it. So, for example, this conversations were sourced from a peer-to-peer support platform, right? There we didn't have any means to take non-verbal cues and things like that. And today, if you go to any like mental hospital, they wouldn't give us any conversations to work with. So that is the problem. Yeah. Sir is also like his hands are also tied. Yeah. Yeah. Yes, yes, true, true, true. Those were all removed from the conversations. Yes, yes. Yeah, there has been a work, in some recent times where people have tried to study like good comments versus bad comments from, in some kind of platforms, you also have real-time psychiatrists responding. So layman versus psychiatric response. So what is the difference? How can you judge them? Those things. Yeah, it's there. Okay. So in this work, what we try to do is we want to understand the mental health of the user better by understanding the association of mental health with affective factors such as sentiment and emotion. So this work is titled, this is still under review. Does sentiment and emotion affect mental health? A multitask classification framework for comprehensive understanding of mental health, emotion, and sentiment from motivational conversations. So the motivation behind this work was like that identifying mental health conditions is a challenging task, right? Like I mentioned, people who share these kind of informations often have similar linguistic patterns, nuances of communication. So it makes it difficult to identify the true mental health conditions. So investigation of the interconnection of mental states with affective factors such as emotion and sentiment can actually help us discriminate between different mental health conditions because these affective factors actually influence how we think, feel, and behave, collectively shaping our mental well-being. The contribution was that we studied the task of mental health disease identification in a multitask setting where we treated emotion recognition and sentiment analysis as a secondary task, which is aiding the primary task, which is mental health disease identification, disorder identification. And for this, we also use the Motivate dataset. We extend the dataset for this task, and we showed that the multitasking gave us better performance compared to standalone mental health variants. So when we did create the data set, we did not annotate it for the emotion and sentiment categories again. So we followed a semi-supervised approach to acquire silver standard tags for these tasks. So what we did for emotions, we took a model, emotion English distill robota based model, which were trained on well-known emotion data sets, for example, MELD, Go emotions. And this model was trained on Plutchik 7 emotion categories. So we simply use this model to get silver standard tags on our data set. Similarly, for sentiment, we used an open source BERT-based sentiment model, which was trained on social media datasets for the task, and we simply used and got the silver standard. I call it silver standard because these tags are coming directly from a classifier. The tags could be incorrect. These are not gold standard tags from human annotation. This is the distribution of the data set in terms of different tasks. So we see that for mental health, the data set is skewed or biased towards the depression tag because we have more occurrences of depression conversations in the data set. Similarly for emotion, so, similarly for emotions, we have higher occurrences of fear and sadness in the data set as opposed to positive emotion classes such as joy, and which is collectively visible in terms of sentiment. We have more occurrences of negative as opposed to positive sentiment. And this is quite the expectation in these kind of data sets, right? Because people are here to discuss their struggles and worries, which are often meant to be negative in nature and not very positive. So here I will try to understand some true correlations of mental health with these affective factors, emotion and sentiment. So this is for the emotion. We see that there is a clear association between fear and anxiety. Also association between sadness and depression. Also in terms of anger, we see that anger has almost equal probability of being associated with depression and PTSD, which means that a person who is suffering from anxiety is more likely to be fearful. A person, say, who's suffering from depression is more likely to be sad. So the presence of these external information or affective factors will help us to discriminate between mental health conditions. Below we have it for sentiment. We see that most of the instances in the data set belong to either negative or the neutral class. And we see that the negative category has almost equal probability of being associated with any four of the mental health disorders, right? So no clear cut correlation. it has equal probability. But in emotions, we see that there are clear-cut correlations that the model will ultimately leverage from. Like I said, we propose a multitasking framework, a very simple, straightforward multitasking framework known as the Core Fusion Network, which has 3 components. We have the feature extractor. Here we use 2 feature extractor, mental BERT. So it's a version of the BERT model, which is trained on huge amount of mental health conversations from social media. And we also experiment with the BERT model, which is an open domain model, a representation model. So we take the embeddings from these models, and then we have the task-specific model, each for each of the tasks, emotion, disorder, and sentiment. So here in this task-specific model, the model learns a token-specific representation using a bi-LSTM layer followed by self-attention, simply the self-attention of the transformer block. And the task-specific representations from each of these tasks are finally directly connected to the task-specific output layer. So in multitasking framework, we have task-specific layers and shared layer, right? So this caters to the task-specific aspect. And then the internal representations from each of these task-specific models is fed to a shared layer, which again contains a bi-LSTM followed by self-attention. And the shared feature representation is also added to the task-specific output layer to finally make the classification. And all these tasks are jointly optimized in a multitasking setting, rather than a standalone setting. So the loss function from each of this is together back-propagated into the network. That's it. And these are the results. So in the top table, we show the results of standalone variants. And here we show the results for the multitasking variant. And consistently, we see that the multitasking variant performed exceptionally well compared to single task variant, at least for the mental health disorder identification task. We also benchmarked our hypothesis using large language models, Google Gemini and GPT 3.5 Turbo, and we observed that our hypothesis still holds there. When you do multi-step prompting, it gave us better results compared to just single step prompting. But the results of the LLMs were not good as compared to our task-specific, our proposed model in this particular task. So these are the results of the tri-task variant. We also experimented in a bi-task variant, right? Just, combining one of the effective factors. Here also, consistently, we see that our hypothesis holds, but with the combination of emotion and mental health, the model performed better compared to sentiment and mental health. Like I said, with sentiment, there is no cut correlation, whereas in emotions, we have clear correlations between mental health and this is what the model, I think, pretty much leveraged from. Moving forward, just the last couple of slides, I'm so sorry. This is the true correlation which I just showed of the original data set. And these are the predicted correlations. Like after the model was trained, what are the correlations that the model learned? We see that almost similar correlations the model has learned, which means that the model is learning valuable patterns from the data set, right? That's it. That's it. And the takeaway from this entire talk is that we see that how VAs can be effective in rendering support in different healthcare scenarios, right? For example, it can elevate the burden of mental health care professionals, act as a private, non-judgmental resource for support seekers to come and seek help. Similarly, in medical care, physical care, it can help in diagnosis potential diseases and allow for early intervention. Some of our future works are focused on, for example, creating virtual assistant in low resource language to cater to different regions, because these kind of technologies can really benefit all the kind of stakeholders, even the doctors there, even the patients there. Also, one of my concerted effort is to, create an explainable healthcare system, because still people have this biasness towards using an automated system. So if we have an explainable system, it can increase the trust of the end users in these kind of systems. And this is very, very important given the current state of the art. And one of my very, very ambitious and long-term goal is to create a unified healthcare assistant that can cater to both mental health conditions and physical health. It is extremely challenging to model correlations between them, but I think in the pace that AI is advancing, anything and everything is possible. So why not think about it? So yeah, that's it. And I think I'll just, these are some of the other works that I do apart from healthcare. So people should not like stereotype me in the healthcare section. I do other things apart from healthcare. For example, social media analysis, effect analysis, social good, for example, education, NLP, legal analytics, recently some work on climate NLP also, and conversational AI that I keep on doing. So thank you everyone for patiently listening to my talk. And I can take up questions if you have any. Yes, sir, please. Yes, sir. So we basically took up instances from the data set and simply prompted the GPT model or these large language models. So given the conversations, can you identify what disease the person is suffering from? Or say maybe I'm also giving you the sentiment and emotion categories. Tell me now what the person is suffering from. So in two different setups. So that's the result. Yes, sir, please. Yes, 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 true. Yeah, yes, yes. Also, because the data set that we are using is not clinical data from a patient or a psychiatrist, it is from a peer-to-peer support platform. So actually, I'll tell you an interesting thing. When I started doing this work, I actually labeled this work as a clinical, but my paper got rejected left, right, center from all top-rated venues. And then Pushpak sir called me one day to his cabin and saying, "Why is your paper getting rejected like this? You've done such good work." And then I explained to him, they know this is what I'm doing. And he just in 5 minutes, he got the core of the work. He's like, no, you can't label the work like this. It should be a motivational assistant because you do not have the data for coming from a real like clinical setup. So this not be labeled as a clinical psychotherapist. It should be like a wellness kind of agent. That's how. Yes, and then the paper just got accepted. Yes, absolutely. It's experience of so many years. We can't even reach that. Yeah. Yes, true. This is five-fold cross-validation average. Yeah. Yes. No, the prompting is just once. In prompting, the results do not change because we do it in a pre-trained ways. So no matter how many times you do it, the responses are going to come the same. No, so the weights are not changing, right? Even then, yeah. No. Same. So with the pre-trained weights, you do it once, you get the same results. You do it again, you get the same results. Yes, it don't change. Yes, sir. Yeah. Yes. Yeah. Yeah. Yes. Yes. It's a question that I do not have an answer to. Like, if we do not have anything, how can we do it? That's the thing. Right, right. Yeah, yeah. True, true. Right, right. But the problem is that these real-time mental health professionals are not open to having some kind of AI system doing their job in some way. So, oh, yes, yes, yes. Assistive tool. Yes, yes, yes. True, true. That is possible pretty much. Yes, yes. TK Shrikant is there. Yeah. Okay. Thank you everyone for joining. Thank you. Thank you.
Thank you all, especially Professor Tulika, for such an engaging and interesting talk, and also all the audience for interesting conversations and discussion. Thank you. Let's thank our speaker again. Thanks.